Hello, welcome to another video tutorial on unit conversions. Now for this video is a follow-up on our previous videos on unit conversions about the seawater. In this video we are trying to calculate the mass of oxygen in the ocean itself, knowing that the concentration of oxygen in our ocean is 8.83 times 10 to the power positive 5 milligrams per liter, or that is parts per million. Okay, so from this value here, we will try to calculate the mass of our oxygen in the ocean. And for us to calculate the mass of the oxygen using this concentration given, we have to remember in the previous video that we have calculated the volume of all the water in the ocean to be 1.292 times 10 to the power positive 21 liters. Alright, so with this given here, we will try to calculate now the mass of our oxygen in the ocean. Alright, so we are starting with the given 8.83 times 10 to the power positive 5 milligrams per liter. That is the concentration of our oxygen. Then we will now try to multiply that with the given volume of the whole ocean to be 1.292 times 10 to the positive 21 liters. So the liter unit will cancel out, obviously, so the volume will cancel out. We are now left with a unit in milligrams. Now, for our first part, we'll try to calculate the mass of the oxygen in the unit kilograms. So we still have to convert milligrams into kilograms, and for us to do that, we have to use conversion factors. And for us to have the conversion factor, we should start with equivalent statements as we did before. So the equivalent statement that we need here are the following. Right? From milligrams, you have to convert it into grams first. So 1000 milligrams is equal to 1 gram. Then from gram, we have to convert that into kilograms. So we know that 1000 grams is 1 kilogram. So we transform this equivalent statement into the corresponding conversion factors and place them here, remembering that the proper units should be in their proper places to cancel out. Alright, so we now have written the equivalent statement in the conversion factor form for us to use them in the problem. So we are left earlier with the unit milligram, and for us to cancel that, we make sure that the unit milligram is in the denominator of our first conversion factor. So that cancels out. We are now left the unit in grams. But we are looking for the unit in kilograms. We still have one more conversion factor here, knowing that 1000 grams is 1 kilogram, and the unit grams should be in the denominator for it to cancel out. Alright, so we've now cancelled all the units. We're now left with the desired unit, which is in kilograms. So what we need to do now is to calculate all the necessary calculations and to arrive at our answer. Okay, so after doing all the calculations, we arrive with our answer, which is 1.14 times 10 to the power of 21 kilograms. So this is the amount of oxygen in the whole ocean in the kilogram unit. Okay, our next task is to convert this kilogram unit into the unit metric tons, which is another common unit of mass for large quantities. Alright, so we need one more equivalent statement, and that equivalent statement is 1 kilogram is equal to 0.001 metric tons, or that 1 kilogram is 1/1000 of your metric ton, and we've seen that in the previous video. So we need this equivalent statement in the conversion factor form for us to cancel the unit kilograms. Okay, so I've now written the equivalent statement in the conversion factor form, remembering that the units should be in their proper places for them to cancel out. So the kilogram unit cancels out because we have placed the kilogram unit in our denominator here. And we are now left with our final unit, which is in metric tons. We do the calculation to get our answer. Alright, after doing the calculation, we have now the answer 1.14 times 10 to the power positive 18 metric tons. Alright, so for this video, we're asked to calculate the mass of the oxygen in the ocean, knowing the concentration of the oxygen and the volume that we have previously calculated in the previous video. And our answer will be 1.14 times 10 to 21 kilograms, and in metric ton unit, that is 1.14 times 10 to positive 18. Okay, so that's all for this video. Thank you for listening and continue learning.